We are taking the first chapter, that is the rational number. So we have frequently come across certain equations like this: x plus 2 is equal to 13. Now this kind of equation, what is the solution of this equation? There's a certain way, means you have to put something in this x so that when it adds to 2 it becomes 13. So when we solve it, if we can just solve it, we can subtract 2 from both the sides, that is minus 2 here. Then 2 gets cancelled and 13 minus 2 is 11. So it gives you 11. So x is equal to 11, which is actually satisfying this equation. So this 11 is actually the natural number. Natural numbers are the natural counting numbers, and these are called natural numbers. But if we take an equation like this, x plus 5 is equal to 5. Now we again want to solve some value or x for some value, so that when we add this to 5 it becomes 5. So the possibility is, if we subtract both sides by 5, we get what? We get 0. This gets cancelled out. 5 minus 5 is 0. So you get a whole number, 0. What is this whole number? Natural number, that is the counting numbers 1, 2, 3, along with the possibility of 0. These are the whole numbers, right? Now let us take one more equation like this: x plus 18, which is equal to 5. Now in order to solve this, if we subtract both sides by 18, we get 0 here, but on this side we get minus 13. So what is this number? This minus 13 is not a whole number. So this comes under the category of integers, which is positive and negative, which can be negative and positive. So if I can show you it on the number line like this, these are 1, 2, and so on and so forth. Similarly, on the left hand side we have minus 1, minus 2, and so on and so forth, right? So these positive numbers are actually corresponding to the natural numbers only. So all these equations like this, 2x is equal to 3, 5x plus 7, now falls under certain different categories. For example, if I want to solve this 2x is equal to 3, let me divide both sides by 2. It gives you x is equal to 3 by 2. So this 3 by 2 is neither a natural number, nor you can say it's not an integer. So it doesn't fall in these categories which we discussed. So this is actually a rational number. Rational number means any number of p by q form, a numerator and a denominator. So this comes under the category of rational numbers. Properties of rational numbers. Closure property. This property says that when we add two numbers, means if we add two whole numbers are natural numbers inclusive of 0. So if we add two whole numbers, you'll get a whole number. If you subtract two whole number, you are going to get the number which is not a whole number. So when we talk about the closure property in terms of whole numbers, for addition it's okay, but for subtraction you get minus 2, which is actually not a whole number. If you multiply, see, if we multiply 0 with 3, 3 with 7, any number which are whole numbers, so a into b, you'll get a whole number. Otherwise, if you divide 5 divided by 8, which is 5 divided by 8, is not a whole number, that is, you can say that whole numbers, they are not closed under division. So the closure property is different for different operations. When we talk about the properties on integers, when we add two integers, that is, if it is a and b, if we add two integers, you'll always get a number which is in turn will be an integer. When we subtract two numbers, again we'll get a number which is actually again an integer. So now the integer is closed under addition also and subtraction also. When we multiply, again we get a number which is an integer. See, 5 into 8 is 40, and if you multiply some negative numbers together, you always get a number which is positive and it is an integer. So a into b, or a and b, they are also an integer. But when we try to divide, like 5 divided by 8, where 5 and 8 are integers, you don't get a number which is an integer, because here you can see the example here. So we can see that the previous three, means multiplication, addition and subtraction, in integer terms, they are closed, but for division it is not closed. When we talk about rational numbers, as we indicated, rational numbers are the numbers which can be written in the p by q forms. When p and q are integers, q should not be equal to 0, because anything divided by 0 is not defined. You cannot divide anything by 0. You have to have some number here. These are all rational numbers. So these are all numbers. Any numbers can be written as p by q form. How? -2. I say it's a rational number. How? I can divide it by 1. So you know how to add two rational numbers now. If you want to add two numbers, I'll just give you a very good way. See, first of all, we have to find out the LCM of these two denominators. So I'll give you a very good idea. You just multiply 4 and 11, 4 into 11. Then you multiply 7 with 6. Then you multiply the denominator, 7 into 11. So this is the solution. For all this you can do just retaining the sign. So when you add, when you subtract, what you get? When you add two rational numbers, you get a rational number. When you subtract two numbers, you get a rational number. That is, rational numbers, they are closed under addition and subtraction as well. Because ultimately, subtraction and addition are nothing but, see, a plus b. And when you subtract, what are you doing? You are adding the negative of that number. So when you take the difference also, you'll get the number which is a rational number. So a minus b also will be a rational number if a and b are rational number. How about the product? When we multiply to p by q form, you'll get always a rational number. So if a and b, they are rational numbers, you multiply a into b, you get a rational number. And when you divide, see, this is one number, this is two number, and these are both the p by q form. So when you divide this, see, just devoid of 0. That means if you ignore 0, the rational numbers, they are not closed under division. So if you exclude 0, then the rational number will be closed under division. Because if you see this example, we are getting some minus 25 by 6. So you're getting, in this case also, you're getting some number which is a rational number. And this rational number is, because as I said, that you cannot divide a by 0. So you just have to exclude 0 to make this, or to indicate this as the operation which gives you a rational number which is closed under division. Commutativity. Now commutativity means when we commute, that means we are going from here and there. So exactly that is happening in whole number. When you commute, if you add 0 with 7 or 7 with 0, addition is commutative, you'll get the same answer. Subtraction, multiplication, division, right? If you subtract, you'll not get the same number. Say I multiply 2, say subtract 2 with 7, 7 with 2, you get different result. Multiplication is commutative, division will not be. You can try it out, because division will give you certain numbers which may not fall into the category of whole numbers. Integers also, when you add, or you can say commute, if you say you're adding 2 with 3 or 3 with 2, you will get the same integer, means the number which is an integer falls under the category of integer. When you subtract, again you will get some number which may not be, because subtraction is not commutative here. Because what happens here is, I'm not talking about the closure property, I'm talking about the commutative property. That is, if 5 minus 3 is not equal to 3 minus 5. These two are different numbers, so subtraction is not commutative. And multiplication is also commutative, because if you multiply 2 with 3, and 3 with 2, you are going to get the similar result. Division is also not commutative. You can try it. Rational numbers. When we come to rational numbers, when we add two rational numbers, that is P by Q form, you see that the result will always be a rational number. Two rational numbers, they can be added in any order. So if you add P by Q with C by D, or rather you can add C by D with P by Q, you are going to get the same result. So A plus B is equal to B plus A and B both are rational numbers. When you subtract the rational numbers, since the results are going to be different, that is why we say that subtraction is not commutative for rational numbers. When we multiply, there will be no problem if A cross B and B cross A. If you commute A and B, multiplication is going to give you the same rational number, so it is commutative. When we divide two numbers, see, this divided by this is not equal to this one divided by this, as you see here. So the expression on both sides, they are unequal. So that is why division is not commutative for rational numbers. Associativity. Associativity means if you add, that is add two whole numbers, it will be associative, means you'll get the value properly if you associate also. I'll give you an example. And then subtraction is not associative here, right? Because we have four operations on whole number: addition, subtraction, multiplication, division. If you multiply, see, this is a sort of a way to explain, means 7 into 2 into 5. What I'm saying is, do 7 into 2 first, like this, and then multiply by 5. The result will be same on both the sides. So multiplication is associative. When we divide, you will not get this, means if I divide 2 divided by 3 divided by 5, this is division, okay? So if I divide 2 by 3, then the result will be by 5. It may not give the same result as if I divide 3 divide by 5 and then divide it by 2. Integers, for these four operations, addition, this is associative. If you add these two together, and add with the third one, it is not going to give you, a different result. So the result will be same. So A plus B plus C is equal to A plus B plus C. If you add these two first, it doesn't matter. In the subtraction, it does matter because the sign will change. That is, subtraction is not associative under integers. The multiplication associative, you multiply this with this first, this with this first, any way you can do. Multiplication is associative. But when you want to divide, see, minus 10 divided by 2, first you divide these two, then divide by minus 5, or you do other way around, you divide these two, then divide the result by minus 10, the division will be different, the result will be different. So division is not associative. Rational numbers. Rational numbers, when it comes to addition, see, when we add this, or when we add in this way, means I'm adding these two first, or rather I'm adding these two, or I can take these two together also. So if we see here the result closely, these two sums are equal, or rather any other way you can combine these, the results will be same. So addition is associative for rational numbers. So A plus B plus C means B plus C you are adding first and A plus C you are adding here. So these remain same. When it comes to subtraction, you will clearly see in these two results, the results will be different. So subtraction is not associative with respect to rational numbers. When we come to multiplication, there will be no problem if you multiply these two together first, or these two together first, or rather A into C into B. It's not going to give you a different result. So the multiplication is associative with multiplication. Division, yes, here the things will be different. If I take these two and divide it by half, or if I take these two and then the result will be 2 by 5, the results are going to be different. So we can say that the division is not associative for rational numbers. Let us take few examples. This is what we can do, how to add these all, as I just suggested earlier. You can take the LCM of this, 7, 11, 21, 22. which comes out to be 462, and then you can just add the numerators because now you have made the denominator as the LCM, and the result will be something like this. You just have to perform these operations, simple operation. We can also solve in some different way. You can combine these two, use this one and this one, and this one and this one. Why? Because 7 is the multiple, or you can say 21 is the multiple of 7, 7 is 21, and 22 is the multiple of 11. That is why we have combined it, so that the formation or the computation of LCM becomes easy for us. 721, we know 21 will be the LCM, here 22 will be the LCM. So easily we can add them. Finally, you get the same result. So in this way, we can give one more example. So if you want to combine these two, multiply these two, we can multiply these two, and the result is going to be half. Or we can take in another way, means we can use the commutativity and associativity. Means I'm taking now this with this one and this with this one. Multiply them. Why we are taking this? Because 4 4s are 16, 5 3s are 15, 3 3s are 9, 7 2s are 14, and you're going to get the result which you wanted, and the computation will be quite easy. So this is the first part of the discussion. I will be taking the rational numbers later also. Till then, thank you so much and take care of yourself.